Welcome to Water Supply and Wastewater Engineering course. So, in this lecture, today will be our lecture number 3 and unit number 2, that is water quantity and intake details. So, if you recall, in the lecture number 2 and in lecture number 1, we have discussed about different parameters, different characteristics of water, then the intakes or the source of water, right? And then in lecture number 2, we have discussed the water quantity, means how much quantity of water is required for a city. So we have seen the different methods to compute the quantity estimation of water, right, for the water supply treatment plant. So in this lecture, lecture number 3, today we'll be discussing about intake, pumping, and the conveyance. So before starting into our today's lecture, let me give a brief introduction. Already I have explained earlier, but still for keep you in track, I am just explaining that what we'll be doing in the water supply. So in water supply, basically we'll be collecting, maybe somewhere river is flowing, right? So we'll be collecting the river for collecting the water from the river, and we have the water treatment plant, right? So this water will be bringing into water treatment plant. In that chamber, multiple chambers will be there, right? So depending on the impurities, it will clean or it will filter the water at the different chamber. Then the clean water or the treated water will go to a different household, right? So like that water will be distributed. So that is basically the water supply part. So in that, in the last few lectures, so we are following a systematic path for this course, so that you can exactly correlate what is happening in the field simultaneously. So what initial days or lecture number 1, basically we have discussed about the types of sources, because for what treatment of water or for distribution of water we need the source of water, right? So the source of raw water, we have discussed different types of source like surface water and underground water. All these things we have discussed in details. And then we have discussed what are the characteristics of water, like the physical, chemical, as well as bacteriological characteristics are there. Next is how much quantity of water is required, right? For this every day, how much quantity of water is consumed by the city or by the village. So that much water you have to treat it, right, in the water treatment plant. So that water quantity estimation, we have done it in details, and we have solved a couple of problems also in the last class. So in this lecture today will be, so no, the next step will be what? To collection of water, right? For the treatment we need to collect the water, right? So we have identified the source. Either it may be a surface water or it may be a underground water, whatever it may be. First, we have identified the source of raw water. So now the next step is the intake. Intake means we're collecting the water from the source, right? So that will be our next step. So, and how we are collecting this water from the source. So in this lecture number 3, we'll be discussing that the intake structure means how we are collecting the water, and the conveyance means how water is flown from the intake structure to the water treatment plant, and ultimately from water treatment plant to the household. So that part we'll be discussing today, that is intake means intake structure. Then pumping, because to collect the water from the river or any water stream, we need to pump the water, right? Because we have to bring the water from lower level to higher level. So that's why we need the pumping as well. And lastly, the conveyance is also required, means the water is transported, right, from the source to treatment plant, again treatment plant to the household. So this is called conveyance. So that also we'll be discussing in this lecture. So the intake. So intake, the basic function of the intake structure is basically to help in safety withdrawing water from the source, okay, over the predetermined pool level, and then discharge it into the water, into the water, into the withdrawn conduit, right? What happens? So this is actually a intake structure, you can see. So this is a dam. You can see this is somewhere in India, some location there is a dam. The reservoir is there. Maybe here in this location you have the reservoir, so water is accumulated here. So now from here basically we are collecting the water, right? Through pump, this water will be passing. So this structure we call it intake structure. So this intake structure you may find it in the middle of the river also, where if the source of water is river. So depending on the source of water, basically our intake structure also varies. So this intake structure is from the reservoir or from the river. This type of intake structure we use. So basic function is basically to collect the water from the water surface, from the source of water. So then through pumping, the water will be taken up, and these pipes are connected. So through pipe, basically water will be going to the water treatment plant nearby. Okay, so that is our main objective of the intake structure. Now, what are the factors governing the location of the intake structure? Because now you understand already that the for the pre-treatment purpose we need to collect the water, so that water collection is done through the intake structure. Now, where will you place the intake structure? Now, already we have identified. Okay, so this is a river flowing nearby a city. So you have a city maybe here. Let me draw it. So here you have the city. The entire any city maybe, and the river is flowing in this direction. Okay, so now you want to supply the water to this entire city, and this is the river. That is our source of water. So what we'll do, we'll collect the water and then we distribute it, right? So now where will you place the intake structure? That is the question. That factors affect, governing the location of the intake structure. Now we understand we need intake structure, right, for the collection of water. Now where will you provide? Will you provide uh, in this location intake structure, location one, or you will provide here construct location structure here location 2, or you will take here location 3. So like that many locations will be there. Now how do you choose that which section or where we should provide our intake structure? Like just now we have seen how intake structure looks, right? So where will you provide? So the you can choose that. First you have to identify that where you will place your water treatment plant, where the land is available, right? So there first, and again the terrain also, like how the terrain, where the hill region is there, where the flat, where the slope is there. So all this factor depends. So once we know that, okay, we will place, or we will design our, we will construct a water treatment plant here, then obviously near as possible we should have the intake structure, right? So if water treatment plant is here in this location, then the intake should be here, so that very shorter distance the water can reach to water treatment plant. Okay, if water treatment is plant is here, and you cannot construct intake capacity here, intake structure, because it will take longer distance to travel to reach here. That's why the first possible, as far as possible, the site should be near to the treatment plant, so that the cost of conveying the water into the city is less, right? So that should be that should be taken care. Now the next is, now here we have the three locations, right? So from where will you collect it? See, the river is coming from this side to this side, and here we have the city. So from the city, basically many industries, household, everything drains. So many things will be there in a industry in the city, right? So they produce so much wastewater. Again, this wastewater also comes into this river. So in the downstream of the river, so this is the downstream, right, and this is the upstream of the river. So in the downstream, basically the water pollution will be very high, because all this wastewater will be coming into this river, maybe through this here, and downstream the population will be very high here, whereas here the population will be less, right, because this entire waste is coming after, towards the downside. So that's why the water intake should be at the 1, not at the 3, because at the 3 basically it is already passes through the city, and so much of the water is polluted. So here at the first location 1, basically you will get comparative cleaner water. So the intake capacity also must be located in a purer zone of the source, to be drawn for the best quality of water from the source, thereby reducing the load in the water treatment plant, right? If you have the more pollutant water, then the load means the load in the water treatment plant also will be very high. So that also we should reduce like that. Okay, so now the intake must never be located at the downstream or the vicinity of the point where the disposal of wastewater, like where the disposal of wastewater is happening. So below that we should not take any intake structure. It should be above the disposal of wastewater. The site should be such that as to permit greater withdrawal of water if required at the future time. Okay, because as I mentioned in the earlier lecture number 2, also we have discussed one very important term called the design period. So design period is basically, today we construct a water treatment plant, and this water treatment plant should be serviceable for the next 25-30 years. So that is, we call it design period. That's why we did the population forecasting also, if you recall in the last lecture. So now the intake capacity, because also should be such that in future the demand will be very high, right? Because the city's population will increase, so demand also will be high. So in that case, the intake structure we should be designed, or should be located such that in future also it can extract the greater quantity of water. Okay, so such that we have to place it out. So the intake structure must be located at the place where it can draw the water even during the driest period of the year, like during the winter time. So during the winter time, if you see, the river will be in dry condition, means the water level will be very less. So that's why intake structure also should be in a such location that even the winter time or even the driest period, even say during the summer time also, you can collect the water from the water body. So if you construct it at the middle of the river, then maybe at the every time all the year you may get water. But if you construct intake structure near to the near to the near to the coastal, near to the boundary line of the river, in that case during the summertime or during the winter time, the water may not be available in that region. So we have to choose intake structure in such a location that even in the driest period also we should take the water, we should get the water from the source. Now the intake site should be remain easily accessible during the flood also, right? After during the monsoon time there may be a flood. So during the flood also our intake structure should not be flooded, means it can be accessible, because we have to supply the water. Even during the flood also we have to supply the clean water to the household, right? So during the flood time also our water treatment plant should work satisfactorily. So in that case, during flood hour time also we can access this intake structure, and it should be placed from the above the flood level, right? So that during the flood hour also, and flood water should not enter or should not be considered in the vicinity of the intake structure. And also the weight of the intake structure also should be high, because here during the flood time the water current is very high. So in that case our structure should not be washed away. So that's why the weight of the intake structure also should be very high. So all these parameters we have to consider, right? Factors we have to consider while selecting the location of intake structure. So intake structure will be always choosing the upstream of the river, and these are the possibilities we have discussed in details. Now the next important parameter is the design consideration. So in the intake structure also you saw already, it is RCC structure, this is a reinforced concrete structure. So for that also we have to consider some design considerations. What are the design considerations while constructing this structure? Is a sufficient factor of safety against the external force, right? Because this intake structure is actually middle of the river, right? So middle of the river you have the, so water is flowing here, very high pressure is there, and we have the intake structure at the middle of the structure, middle of the river, right? That's why it will be subjected to very high extreme current, water current will be there, right? So similarly floating objects, even if floating soil objects is passing, that also will hit the intake structure. Similarly during the flood also water level will increase, ultimately pressure also will increase. So, and maybe if the river is nearby, in a polar region, then maybe ice also will be coming in during the some winter time, so that our intake structure can take the ice pressure as well. So that is our primary design consideration while designing this RCC structure. Similarly, should have sufficient self weight, because the structure is on a water, right? So that's why the water thrust will be always up thrust will be always applied on this structure. So our structure should have sufficient weight, so that it is not washed away during the water, during the flood time, right? So that was, so structure should have sufficient self weight so that it does not float by the upthrust of water. So these two are very much important extra precaution you have to take care while designing this intake structure. So now another next important parameter is pumping. So already we have seen that how water is from the through intake structure, basically water is collected, right? So once you collect, but again the intake, the water level will be here below, right? At the river the water level is at lower, but our water treatment plant will be at the higher elevation from the river level. That's why we need to use pumps for collecting the water from the intake structure. So pumping is basically a device which converts mechanical energy into hydraulic energy, right? Basically pump, one motor will be there, right? In the pump, and that through that suction will be created, and through this suction basically it pumps or it takes the water from the downside to the upside. So it lifts the water from the lower to the higher level and delivers it at high pressure. So that is also important, high pressure, because every day we have to filter out that much quantity of water, so we have to collect the water in high pressure. So pumps are employed in water supply projects at the various stages, and this is the below. So pumping is very much important in entire water supply system. So pumps are required, like even from the collection of raw water. In the last slide I have explained the intake structure, right? Intake structure means where we are collecting the water from the source. So there also we need pumping. So pumping is required to lift the raw water from the well or from the river or from the any source, right? That is we need pump. So to deliver the treated water, so once you collect the water, you convey that through to the pipe. Basically, the raw water reaches to the water treatment plant. So in the water treatment plant, water purifies, and ultimately from water treatment plant, water goes into the household and in the industry of the city, in a city. So that's why. So in that case also you need the pump, right? To supply the water to the household, you need pumps. Then again, water has to be distributed through pressure, right? Because so that more quantity of water can be delivered at the location. That's why to create the pressure even in the water treatment plant, in the pipes, basically we use the pumps. So to boost up the pressure in a water mains, so sometimes what will happen is that from the distribution, while distributing the treated water, so one will be the main pipe, right? These main pipes will be all around the city. So from the main pipe, again sub pipes will be taken out, where the from the sub pipe, basically water distributed from the locality area, right? That will be discussed more details in the when we'll be discussing about the pipe networks. So even during the to increase the boost up pressure in the water mains, we need pumps to fill the elevated water tank, right? In some villages you will find the water treatment overhead water storage capacity is there, water treatment tanks are there, right? Overhead means in a RCC structure will be constructed at the top. Basically we have the water treatment plant, right? Something like that structure will be there. So water treatment plant will be there from the ground. So this water has to be pumped up, right? And it will be stored in this water treatment plant, water storage tank at the maybe this height, maybe sometimes 30 meter to 30 to 40 meter, right? You can imagine it is very high structure. So water has to be pumped from from ground level, and it should store here. Now, the next purpose required for pumping is the to backwash filter. So, even in the filter, that is water treatment plant, also we need to wash our filter. So that also we'll be discussing in due course in details. What is the backwash filter? But in that purpose also we need pumping of water. Then to pump the chemical solutions needed for the water treatment plant, right? In the water treatment plant, we add other chemicals also to purify the water. So to add the water, the chemicals, again we use pump to supply the chemicals solution into the water treatment. So you can now understand that pump is a very much important parameter in the entire water treatment plant. So to transport the water from even raw water to the water treatment plant, we need pump. Again, from the water treatment plant to household and in industry, where water should reach, right? In that also we need pumping. So pumping is very much important parameter, very much important segment or component in the water treatment plant. So now the classification of pumps. So based on the principles of operation, pumps may be classified into following ways. So first one is displacement pumps. Already I think this different types of pumps you have studied in the hydraulics course. So in the displacement pump, basically it is the reciprocatory rotary type. Similarly, velocity pump, that is centrifugal or you know turbine or the jet pumps are available. Like different types of pumps already you have studied in the hydraulics course. Similarly, buoyancy pumps as well as impulse pumps. So depending on our availability, depending on the purposes, we use different types of pumps, and each pump can be used for the particular for the particular purpose. So now the capacity of pump. So work done by the pump, that is equal to gamma into q h by 75. So this is a standard formula we can use on how much work done by the pump. So what is gamma? Gamma is basically the specific weight of the water, right? That already we know. Some standard value will be there for the specific weight of the water, kg per meter cube. Q is the discharge of pump, means how much water is delivered into the water treatment plant, or from the how much total water is there. That is q, that is meter cube per second, right? Per second, how much water is delivered, that is q. And h is the total height against the pump. So from lower level to higher level, water has to reach, right? So what is the total height? So that we call it capital H. So if you just divide by 75, so this h is the total height. So h is basically hs plus ht plus hf plus loss. What is hs? Hs is the section head. Section head means in where the water is there, suction head. Similarly, delivery head means where we have to deliver the water, deliver the water, that is HD. So that is, if you add HS plus HD plus HF is the friction loss, because water is going through pipe, right? So the pipe also produces friction loss in water. So that also comes here, HF. So if you add all these losses due to exit and all losses also, then you will get total head. So this total head will be provided here, then you will get that much work done by the pump, that is gamma QH by 75. Okay, so that is the total work done by the pump. Then the efficiency of pump E equal to gamma QH by brake HP. Okay, so that formula, all these formulas you guys have studied it in the hydraulics course, so I am not going into much details about all these capacities of pump, these equations, and because already you know all these things. So always we provide even number of pipes, like 2, 4, 6, something like that, with the total capacity of of equal to the total BHP and how much required basically to, and provide, and always we keep half pipes in a reserve, right? Because as I mentioned, pump is very much integral part of the entire water distribution system. There is collection to distribution, everywhere we need pumps. So there is a very, as pump is a mechanical device, there is a high possibility also sometimes pump gets damaged. So in that case also, always we should have some extra pump standby, so that during the emergency time also we can use the extra pump for the um, for when it is required. So now, as I mentioned, pump is very much important. Next is the conveyance. Conveyance means what? Water is distributed, right? From water is collected through intake structure, and it is distributed and it is transported to the water treatment plant. Again, from water treatment plant, water goes to the household. So there are basically two types of conveyance you will find in the entire water treatment plant. So first type is basically when you collect the water from the from using the intake structure from the river source. So, and from there basically water is transported to the water treatment plant, right? So that is first type, means conveyance of water from the source to the treatment plant. And next type of conveyance or water transportation will be happening from the water treatment plant to the distribution system, means the household water is transported. So in the first stage basically water is transported by the gravity. Sometimes what happens, you have the river is flowing right like that, and you have the water treatment plant here. So what will happen is some type of canals they construct. So these canals are actually constructed, and through this canal basically water is flowing from river to directly to the water treatment plant. So that is through gravity road, basically by the gravity itself we use the gravity slope, and water is reached here. So that is one type of water, conveyance of water. So, or sometimes we use this, like in the first slide, I have shown one structure, right? That is intake structure. So in that, sometimes we have to, we use palm for that, for for collection of water. So water is kind of collected from the source to the water treatment plant, either by gravity or by pumping also, depending on the location of the water treatment plant and depending on the availability. And in the second stage of transmission, that is from water treatment plant to the household, again we are distributing, right? That is the second stage, where some in maximum case we use pumping. And why we use pumping? Because in that case, because the water is distributed in the entire city, right? In that it is very difficult to maintain the slope by gravity where water passes. But here this is actually an outskirt of the city where we can make the slope, whereas here while distributing the water it is very difficult to make the slope, because already the city is developed, already constructions are there. So in that case we use pumps for the transmission of water from the water treatment plant to the distribution system. So as I mentioned, in the rural areas we use this overhead water tank where we store the water. So in that case, through pump basically water is stored into the overhead tank, right? And from there by gravity basically water will be distributed to the entire household. Okay, that is the hybrid system of where we follow. If you have the overhead tank, so water is through pump, basically water is pumped into the overhead tank, it is stored there, and from there by gravity itself water is distributed to the nearby areas. Okay, so that is the conveyance. As I mentioned, there is two part. Okay, now you understand the conveyance part. Now the next is the pipes, right? Which pipe we follow for the collection of water, for the transportation of water. So basically there are two types of conduit systems are available. So one is free flow system. What is free flow system? Basically, as I mentioned, these canals we construct, right? This is free flow, means water is flown on a channel or something like drain type structure. In a channel, water will be flown. It is not in a pipe, it is flown. So it is free flow structure in the system. The surface water is conveyed section flows freely due to gravity, right? We make the canals, so from this canal water will be flowing. So this is, and surface is the open, right? That's why we call it is a free flow system. So free flow system, it is often necessary to construct very long conveying sections to suit the slope of the existing ground. So if so in the free flow system, basically sometimes always it is we use the gravity itself, because here this is the river, okay, and we make this type of canals from the river, right? And it should be, downstream, so slope should be downward, that then only water will flow here, right? So in an open flow system, basically here we do not use any pump, right? Because where will you attach a pump? It is an open free flow system. So water should go by gravity force itself. So we have to make the slope such that water should automatically flow and reach to the water treatment plant. So here we do not use any pump. So as the water should go by gravity itself, that's why sometimes we need to have the very longer route also, because we have to use the ground slope, right? In that case, directly may not reach water directly in straight line, may not reach to the water treatment plant. We may use some other line, but during the slopy line we have to follow, and then only water will reach. So in that case, the water water may take the longer distance while reaching into the water treatment plant. Similarly, the water pressure also may not be high, because the water is coming by gravity depending on the slope. Basically, if you have the high slope in the entire system, entire canal, then obviously water pressure will be high. But if the slope is less, then again the pressure will be less in the water treatment plant. So this is one type, and the next type of water that pipe system is the pressure system. So what is pressure system? Pressure system is nothing but a piping that the big conduits will be there, right? Conduits will be there. Here water will be passing from another to another site, and there basically we use pumps to collect the water. So in pressure conduit which are closed, the pipes are closed, right? Which are closed, the water flows under the pressure above the atmospheric pressure, because here we are using pumps. So basically water is flowing uh, you know um, from the pressure. The bed or the invert of the conduit in pressure flow is thus independent of grade of hydraulic gradient line, or it can therefore be follow the natural available ground surface, thus require lesser length of conduit. So what will happen here? Here actually we are not dependent on the ground slope, because here we are using the pumps in the pressure system. So whether it is ground surface, or whether it is plain or it is slopy, it does not matter, because we are using the pumps. So very quickly water will go. So this, depending on the construction material, these pipes may be either made up of cast iron, or maybe sometimes we use RCC, big pipes for transportation of water from one side to another side. Or we may use that cast iron or rough iron or brass copper materials. So sometimes we use plastic pipes also, right? In domestic usage we sometimes use the plastic pipe also. Glass reinforced plastic pipes also used nowadays. So different materials are available to construct, and depending on our purposes we choose which type of material we use, and we design the entire pressure system. So now in the hydraulic design, now in the pump system you understand, now in the pressure system basically water passes through pipes, right? Passes through the pumps. So now the design of water supply conduits depends on the resistance to flow, available pressure head, and the allowable velocity of water. So generally we use this formula, right? Hagen-Williams formula, basically to find it out of how much velocity of water is there in a system, and how much it is required. Hagen-Williams formula and the Menin's formula. So these formulas you have studied in the hydraulics course in details. So here I am just showing the formulas, but I won't be discussing much details about this formula. So these two popular formulas we use for how much how much q or how much water is discharged, that is q is with this formula, and these are the different parameters, and the hydraulic radius, right, hr is the how much is the radius of pipe, and s is the how much is the slope. Okay, c is some coefficient, right, n is the maintenance coefficient, c is Hazen's coefficient. Okay, so with this, if you plug in all these values, you will get it how much q is, how much discharge is required. So based on this formula, basically we design the hydraulic structure. Means hydraulic structure means, let me draw it here. So for example, here you have the river, right? So from there basically we are collecting, so we have the intake structure at the middle of the river, and through pump basically we are pumping the water to the water treatment plant. So here we have the water treatment plant, right? So, and we know already how much water has to be treated for this water treatment plant, because through population estimation, forecasting, and all, already we know that in the city where the water will be distributed, in that city how much water has to be treated every day. So now based on that, basically we can design what will be the diameter of the pipe. So design means basically here we are finding out what is the diameter of the pipe, what is the grade of pump required for this treatment plant and all. Okay, so depending on how much requirement we have, we can design what is the diameter of the pipe. So for example, you have to distribute maybe every day 1,000 liter, or more than 1,000 liter, for example 10,000 liter you want to distribute the water in a small village. 10,000 liter, they're very small. So for that purpose, you know how much discharge means, how much quantity you have to distribute, means this u value you know. And this now you can find out what is the r value, because n is anyway constant, that is maintenance constant, you will get it. S is the slope, right? What is the slope from intake to this water treatment plant? How much is the slope, ground slope? That also we can measure it. So you know s, you know constant, you know q, easily you can find it. What is r means the radius, hydraulic radius, right? How much, what is the radius of this pipe, you can easily compute. So like that, using these formulas, basically we can compute the different design parameters for the calculation purpose. Okay, so we use this hydraulic equations to design the entire hydraulic system. So hydraulic system design means we are finding out what is the dimension, a diameter of the pipe, and what is the material we are using for this pipe. Similarly, each component, water will be flowing right from one chamber to another chamber. So in that also we need to use the pumps, and pipes also we have to use. So all these purposes, designing of each parameter, we will use these equations to compute all these things. So in this lecture, what we have discussed, the intake structure. Starting from intake structure means from where we're collecting the structure, collecting the water, and then the pumping means water is pumped from intake structure to it reaches to water treatment plant. Again, from water treatment plant, water reaches to the um, household. So this pumping system also we have discussed, what are the different types of pumps are available, and and what is the capacity of pump, and all these things we have discussed. And lastly, we have discussed about the conveyance, means how water is transported from one location to another location, and what are the types of pipes we are using. So all these things we have discussed in this lecture. Thank you.